in the next case, we will discuss what if the limits are not given to you directly in the question. So how can you find out the variable limits? So in this case, there are two methods to calculate. Actually, there is one method to calculate the limits of integration. So suppose we are to calculate this double integration over the given area A of the function f of x y dx dy. So that means we'll be calculating this double integral over this particular area A. So the first step would be, you would have to sketch the given region. So sketch the given region. So in the question, they would give you some region, that this is the particular region where with respect to which you have to calculate the double integration. So you will sketch whatever is this region in the two-dimensional plane, and then you if you are to calculate, if you are to integrate firstly with respect to x and then with respect to y. Let me take an example. Suppose the area is given to be the region bounded by y is equal to x square and y is equal to x. Now you all know what is y is equal to x. That is a straight line having an angle of 45 degree passing through origin. So it would be something like this, right? And another y is equal to x square, that is the equation of upward parabola again passing through origin. This is origin, this is x axis, this is y axis. So your parabola would go something like this, right? So the region bounded by these two curves, that would be this one, right, in between these boundaries. So here, this is your region A. So first step is done. Now you can do two things. Either you can take a parallel line. So case 1, in step 2, I'm defining case 1. What you can do, you can draw a parallel line to y-axis, say parallel to y-axis. So what you are doing, you are drawing a parallel line to y-axis like this. So in this case, this is the vertical line. So here you will note at which point it enters this region and at which point it ends this region. So here, what is the equation of this line? This line was having equation y is equal to x, and this parabola, this has equation y is equal to x square. So this vertical line is entering this region at this point, and this point corresponds to this particular parabola. So here, what is the value of x? Yes, what is the value of x here? So the value of x would be square root y. So this is at the starting point, and at the end point, what is the value of this x? So x is equal to y here. So these are your variable limits. Now for the constant limits, what we are trying to do, we are you imagine holding up this straight line in your hand and moving it in this direction and in this direction, so that suppose this is some paint brush and you are painting this whole region. So when you move this line somewhere here, somewhere here, somewhere here, somewhere here, somewhere here, so you are actually painting this whole thing. So you are moving from this end to this particular end. So what is the minimum and maximum value of y? So y has minimum value here as 0 and y has maximum value here. What is this value? What is this point? So first of all, you have to calculate this point of intersection. So in this case, the point of intersection, when you compute them, when you solve these two equations, you will get the point as 1, 1. So the maximum value of y here is equal to 1. So basically, in this case, your double integration over the given region of the function f of x, y, dx, dy, this becomes equal to First of all, we'll write the limits of y because they are the constant limits, and then we'll write the limits of x. So they are x is equal to square root y. So obviously your starting point would be the lower limit. This would be the lower limit and this would be the upper limit here. So x is equal to y and the given function f of x, y. So this is how you compute the limits. So that means whenever you wanted to have the variable limits of x, you draw a vertical line, and corresponding to vertical line you compute the limits like this. In the second case, case 2. So in this case, suppose your region A is again defined by these two lines. One line is x is equal to y and another line is this y is equal to x square. So these two lines. So again let me draw them again here. X, y, and this is origin. So this is the line y is equal to x, and we have this parabola, upward parabola. So it will be something like this. Y is equal to x square. Now we have to evaluate this area, this double integration of the function f of x, y. So it would be, first of all, we are now interested to calculate what are the limits of y and what are the limits of x. So in this case, what we are going to do, we will draw a horizontal line like this, parallel to x-axis. So we will draw a horizontal line parallel to x-axis. So you will first note that what is your entry point here and your entry point here, right? And then you will see how far it will go from here and how far it will go down. So that is what you are seeing. So here we'll say we have to paint this particular region. So painting this particular region, you will move your brush like this, so that whole of the region would be covered, right? So here, first of all, we'll see what are the limits of y. So they would be maximum limits of y and then the limits of x, and f of x comma y, dx and dy, right? So the x limit, it would be here, what is the value of x? Its value is y, and here what is the value of x? It is equal to square root y, and here what is the value of y? The value of y is 0, and here the value of y is equal to 1, because we already know what is this. This is the point of intersection and its value is equal to 1, right? So this is how you compute the area. I'm sorry, in the previous case, whenever we have drawn this vertical line here, in this case we will look for the values of y in this direction, because this is the increasing value of y. So this is wrong. We will look for the values of y instead of x. So what is the lower limit for y? The lower limit for y, so here the value of y, that is equal to x. So y is equal to x, and here y is equal to x square. So this is given to us, and here, because you are moving in this horizontal direction, you are moving your vertical line in the horizontal direction. So that means your minimum limit for x, that is the value of x here. So your x varies from which point to which point? Your x varies from the point 0 to the point x is equal to 1, because here the value of x is 0, and here corresponding to this point the value of x is 1, right? So your limits in this case would be not this. So it would be, here you will write the limits of y first and then x. So it would be y, and the limit of y is from x to x square, and the limits of x varies from 0 to 1. So these are your limits. So this is how you can compute the limits. So let us see one question. The question says you are to compute the region or the double integration. So the question is evaluate double integration over the region A of x square y square dx dy, where the region A is the region in the first quadrant. This is given to be the first quadrant, enclosed by x is equal to 0, y is equal to 0, and x square plus y square is equal to 1. So this is given to you. So first of all, what you will do, you will visualize the given region. So that means you will draw this. Now if you see, what is this? X is equal to 0, this is your y axis, y is equal to 0 is your x axis, right? And x square plus y square is equal to 1. This is your circle. Because the general equation for circle, what is that? X minus a whole square plus y minus b whole square is equal to r square. Where what is this r? This is the radius, and your center of the circle, that is equal to a comma b. So here in this case, your center is at 0 0 and radius is equal to 1. So we will have a circle like this. Say this point is 1, this point is also 1. So a circle would be something like this. And we are only interested in the first quadrant, so we are not drawing the other portions. So this is our circle here. This is a region A. Now according to this region A, we wanted to compute the integration of the given function. So what is this integration? Now it is up to you whether you wanted to calculate the variable limits in x or the variable limits in y. So that is why we are saying the double integration over the given area of the function x square y square dx dy, this would be equal to, depending upon whatever thing we are taking. So suppose I am taking this vertical line over here parallel to y axis. So here in this case, the limits of that will be varying would be of y. So here I would be defining the limits of y dy, and then I would be defining the limits of x. So now, and the given function as such, x square y square. Now here what we are to do, we are to first see what are the limits of y. Now here at this point, what is the value of y? The value of y here is 0. And at this point, this is the equation of circle. So the equation of circle is x square plus y square is equal to 1. This is given to you in the equation. From here, you have to calculate what is the value of y. So when you simplify this, you will get y is equal to 1 minus x square square root. So that means your upper limit would be, because at this particular point, the exit or the leaving point here of this vertical line, the value of y is equal to square root of 1 minus x square. So this is square root of 1 minus x square. And now when you shift this vertical line in the horizontal direction to cover whole of this area, so the minimum value of x, that is equal to 0, and the maximum value of x, that is equal to 1. So that means your x is equal to 0 here and x is equal to 1 here, right? So we just have to solve this one. So first of all, we shall integrate this with respect to y. So it would be x varying from 0 to 1 and its integration with respect to y. Here x square would be treated as constant and the integration of y square with respect to y would be y cube divided by 3. And here we will substitute the limits y varying from 0 to square root of 1 minus x square dx. So when you substitute the limits, what would be this? X square by 3 would be as such, and then instead of y we will be writing 1 minus x square raised to power 1 by 2 raised to power 3. So it becomes raised to power 3 by 2 dx. Now we have to solve this one, and we have to write down, we have to substitute the limits in this case. For that, for simplifying it a little bit, what I can do, I can substitute x to be sine theta, so that my dx would be equal to cos theta d theta, right? So in this case, when you solve and simplify this, you will again have to shift the limits. So your limits would change from whenever x is equal to 0, your theta, sine theta would be 0, so your theta would be 0 degree, and whenever x is equal to 1, your sine of what is sine theta is equal to 1, so your theta would be equal to 90 degrees, right? So you can substitute it here. So this becomes integration, it is equal to 3, right? Yes. So it becomes 1 by 3 outside. So it simply becomes sine square theta cos cube theta, and then cos theta d theta. So when you simplify this, your final answer with respect to theta, so your limits theta varying from 0 to pi by 2. So when you simplify this, finally your answer would be pi divided by 96. So that is your final answer. So we can solve one more question. So the next question here is, we have to evaluate double integration over the given area of the function xy dx dy, where what is a is the area, or the area bounded by the x-axis, the ordinate x is equal to 2a, and the arc of the parabola of x square is equal to 4ay. So for the solution, we first have to visualize this. So for the visualization, we will draw all these curves. So first one is x-axis, so this is your x-axis, and then the ordinate x is equal to 2a, and then this parabola x square is equal to 4ay. So this is again the upward parabola passing through origin, so it would be something like this, right? And the ordinate x is equal to 2a, so this would be the line, straight line. Say suppose this is 2a, so your straight line would be like this. So now what is the area which is bounded between these three, x-axis, this curve, that is x square is equal to 4ay, and then this line x is equal to 2a. So your given area would be this particular area, right? So it is very important to determine what is your given area, which is the bounded area. Okay, so now we have identified our given area. This is the given area, so we have to just compute this integration. So how can we compute this integration? The integration over a xy dx dy would be computed firstly by calculating the limits. So for calculating the limits, I am again taking the vertical line over here. So when you take the vertical line, so that means your variable limits, because in this vertical line, what is varying? Y is varying. So your variable limits, that would be of y. So here we would have the limits of y, and here we would have the limits of x, and the given function, that is xy, and then dy first, because we are doing it here with respect to y, and then dx. Now what would be the value of y here? The value of y here is 0. And what is the value of y here? Here you can obtain the value of y, that is equal to x square divided by 4a. So your upper limit is x square divided by 4a. And the when you move this line horizontally, so the minimum value of x is equal to 0, and the maximum value of x is this one, right? That is 2a. So this is 2a, and which is also constant quantity. So now This is how you obtain this, and then you can very easily perform this integration. So you have x is equal to 0 to 2a. Now when you integrate xy with respect to y, so x would be constant and the integration of y would be y square by 2, and then you can very easily substitute the limits y varying from 0 to x square by 4a into dx. So what would be this? It would be integration x varying from 0 to 2a x by 2, and in place of y we will be writing x square by 4a. So it would be x to the power 4 divided by 16a square, and then when you substitute 0 you have 0 here. So it is equal to 1 upon 32a square outside, and then it is integration x varying from 0 to 2a x to the power 5 dx. Now what is this integration? 1 by 32a square as such. It would be x to the power 6 divided by 6 and the limits varying from 0 to 2a. So this is equal to 1 by 192a square into, now you have to substitute the limits of x. So it would be 2a raised to power 6 minus 0 to the power 6. So now we can solve this. So it would come out to be finally 1 divided by 3 a to the power 4. So this is your final answer.